Ladies and gentlemen, welcome to New Jersey. Tonight we're going to be doing is trying to build a tool to put the gear drum detent for a CB750. This one's a 1973 on. The trick here is that this spring here winds around this post here, and this is just a real bear to get enough torque on this to get this all the way around. And this actually has to drop through there into the drum needles and go back in there. We'll see that when we finally get to putting this on. So I haven't been able to find a tool to make this, so I'm going to make one. And what that's going to do is just what I've got laying around the shop here. This is 3/8 inch round bar that I previously used as a drift to push out some valve guides, and did it in a damn hurry. And 3/16 by 1 inch flat bar. The deal being that this is going to have to get drilled out so that it spindles on here, spin them a things this way, and winds up this spring. To do that, this is on here with another piece of this hanging down, so it's beside there, and pulls out the spring this way. Alright, those are all neat words. We'll see how it goes. Someone very observant in the crowd might have noticed that I said this was a Honda, so all of these holes in machining are metric, and this is 3/8 inch round bar, which is imperial, which is how my brain works, but the bike thinks differently. And the metal only thinks one way, and it doesn't go in here. So I don't have a lathe. Ideally, I'd want to turn this part and center drill it and all this stuff, but yeah, I'm on a redneck budget here, so what I'm going to have to do is chuck this into an electric drill and grind it down on a bench grinder. Okay, that is 35 on latits. Okay, and hot dog down a hallway. Alright, well, it'll work. We've got it so the detent lever goes through there. Very easy sliding fit. A little exuberant with the grinder. What's going to have to happen is that this is going to have to spin on this part here, and it's a very fine fit there. But the first thing we're going to do is we're going to cut this in half and set up the arm that's going to pull this here. So we will cut this first, then weld the two pieces together to the 3/16 flat bar, and then drill this hole. Okay, cut the cross piece to length and just broken off the edges and ground a slight taper to the vertical piece, because what we're going to do is drill a hole here and just plug weld it from behind. So now we need to move on to drilling this hole down the center here. And for that, we need to know how big or how wide this piece is. So take a quick measurement here. Okay, and that makes 234 thou. What the hell is that in? Alright, so breaking out camera 2, 234 thou and some change. Let's see. Well, we're a quarter is too big. I've got a 1564. No, that does not work. 1564 by 234,375. Like they goddamn made it for it. Alright, we'll use that. So this is going to be a really clinch moment. This is not the machinery you want to be doing this on. I really wish I could have turned this on a lathe and, you know, had it all concentric and then, you know, bored it out first and turn the outside diameter. But here we are. Wish us luck. Shit. We are not concentric. Shit. Alright, I'd given this up for dead, but I've come up with another idea. You can see that this is just not nearly concentric enough, and it's just going to have no wall here on the side. But I thought of a different way to do this. What I can do is take more of the 3/8 inch stock and drill it first, and it doesn't matter that it's not all that concentric, because then what I'm going to do is loctite it to the drill bit and repeat the turning down process. Let's see how this fails. So that's about what we needed to do, and all we need to do now is get it so this detent lever will slide over there. So to make sure we're concentric to this, we're going to use a trick I saw on Stefan Gotteswinter's channel. I'll put a link in the description, and we're going to Loctite this to this drill bit. Then when we're done with it, we can heat it up and pull it out. Holy shit, that worked. So it's still a little hot, but this now slides. A little roughly, but good enough. And then all we got to do is take this down to about the length of this, and then weld on the cross piece. So now we need a hole just there. Which side of this is actually square? Probably neither. Okay, and then weld that in. Okay, so the hole's got to be 357. So I don't really have an appropriately sized drill bit for this. 5/16, that's 315 thou, 312, somewhere around there, is a little too narrow for that. And then next step up is 3/8, that's 375, and much too big unless you slip it between the flutes there. So I don't have the right drill bit for it, but what I do have is a Chinese end mill, and what I can do is drill the hole and then try to wallow it out with the sides of the end mill. 4 flute looks like. Just gonna take a plunging cut with the end mill. On second thought, my work holding kung fu is nowhere near good enough to plunge cut with that end mill, so we'll just do a drill bit and then we'll try to wallow it out with the end mill. You'd of course want to do this in something like a 5C collet, but I don't have one of those. Then there's the question of why do I have the end mills? I don't have a good answer for that. Of course, the drill press isn't good at this sort of side load, but and it's complaining very badly about it. But we're going to let it. Come on, get in there. We're sneaking up on something that makes sense. but this is a pretty tight requirement, because what's got to happen here is this piece has got to turn here and pull this back, but it has to allow the detent lever by so that it can catch on the other side. So that means we need full rotation here, and we let that on that side, but this has to be just long enough to catch that spring but still let the detent lever by when it's in its lowest position. So there'll be a lot of grinding and fettling, but I think I've got everything cut I need to weld right now. Yeah, that wasn't the smartest thing, because this flat section was supposed to catch this spring here, and it doesn't, because it was supposed to be on this edge, not this edge. So I'll do one of two things. I will grind out this weld and redo it the proper way, or I will use a bit of TIG wire to make a little loop to grab that hook there. We'll see what happens. So, unless I'm mistaken, I think this is complete. This grabs here. This here comes in and lets us torculate. Let's see if we can do the thing we set out to do.
You need me to...
Not yet. take that, push really hard right there.
Where?
With the bar, the top of the detent. You see it?
This
Right
thing?
here. So we're out of options now. This spring deformed plastically under load. Basically, it got around the nut it was supposed to wrap around, or above the nut it was supposed to wrap around, and will no longer function anymore. At a complete loss for how to go forward. This spring is made out of 100% Honda grade unobtainium. Hasn't been made for years. I've never seen one of them on eBay or anything like that or anywhere. Could maybe get one custom made, but I don't really know how to. There's probably a machinist around here somewhere. But unless there's something to actually hold this spring in its spot, it's just going to always lift out like that just for the fact of torquing it. I don't know what that Japanese dude was thinking when he designed this spring, but well, I hope he suffers for it somewhere. Thanks for watching. I'll try better next time.